Hi, it's Kedget UK here again. Update on the 32x. There'll be a part 3, so this is sort of going to be part 2. I'm not really going to cover any sort of repair technique or anything on this, just a few things to do with diagnosing things and explaining what I've done, the progress I've made. You know, this is not the final state here. There's a few things I need to do to this to tidy this up. I guess you could start with, you know, the wires and things. You know, I'm still not happy with the way these are just sort of sat there, and there's a bare resistor end and stuff floating around. The lengths of these wires, when someone originally cut that cable there, you can see you've resoldered it part way and the heat shrink is not covering it and stuff. So there's a whole bunch of things I'm going to tidy up on this just to make it absolutely perfect when I get to the last stage of this. And with the constant moving around of the board and stuff, some of my hot melt glue's come off, and you can see there's a blob there flowing. That one's come off as well. So I need to redo quite a few things, shorten the wires, tidy it up, tidy the soldering up a bit and stuff. You can probably just about see it's a bit of a mess. I actually put a ferrite bead back on there. I need to straighten that a little bit because it was very difficult to the pad size. And in fact, I might need to leave it offset at an angle a little bit like that, because one of the pads, as I described in an earlier video, was damaged and it's sort of shifted to the side. I don't want to try and move it. It's probably better to just leave it as it is, actually, despite it looks a bit of a mess. So yeah, that's got a new ferrite bead in place. The only ferrite beads I had were some 60 ohm ones, which were, I've got a bunch of them. They were intended for Amiga 1200s to do with timing fixes, but I think the ones that are on this board to start with are something like 6 ohm. So even though it's 60 ohm, it works. I think all it's doing is it's filtering the supply to one of the chips. I don't know whether it's this 7.4 logic chip here or one of the chips on the underside of the board, the other side of the board, or what. But yeah, it just filters the power going into it. So that 60 ohm ferrite bead, that works fine. No difference in behaviour since they changed that. I got the 1 picofarad cap there. You can barely see it. When I've cleaned all this up, I'll do it at a macro, so you can see how I've done that. But that's had to go at like 45-degree offset because one of the pads was missing, and I had to use the pad that's sort of to the left-hand side rather than the one that was, you know, directly above to make it a nice straight alignment there. But yeah, so the 1 picofarad cap's on there. That's not made any difference at all. You can probably see I removed that massive blob of solder. There were a load of wire. It was a load of wire. It wasn't just solder. It was, you know, from the original wire that was through the board there. So I cleaned that up, tidied up the that there because it was split. The cable was split and it was barely hanging on. I'm surprised the thing even worked because I didn't have a very good 5-volt supply there. And you can see where I've ripped the tape off, that green tape. There was a big strip of green tape all the way down there. I need to remove the little bit that's still there, and I'm going to lift or desolder that cap. These aren't resistors, by the way. These are caps. They look like resistors. They're not. And put a new piece of tape down there. But the reason I removed that is because I resoldered all of the edges on these chips all the way around that as well. So all of those have been redone just to rule it out, really, and made no difference whatsoever. So it's definitely not to do with us quad flat packs coming off the board. I did a little bit of experimentation with these caps, took some of these caps off, measured them, pretty much all the ones around here, they were all fine. I replaced a few actually just for the hell of it, even though the values were okay. I replaced those 2, I think they're 47, so I replaced that 100, replaced that 47. But to be honest, I mean, when I say replaced, let's say that 100 for example, the one that was on there was reading about 96 or 95. You know, it's not the caps, it's definitely not the caps, but I replaced them anyway while I was there, and I've kept the old ones because they can, you know, they are okay. The ones on this side I haven't bothered with. This is all to do with the video synchronization stuff, so I've got no issues with that. I do know that has been tampered with. That potentially could cause me some issues. It's, you know, the thing's working as it is at the moment, but I can tell. I measured that on my capacitance meter, and it's very, very, it's wildly different to the one on the other board. So someone has been tinkering with that. I might need to get a frequency counter or something. I'm thinking about getting a new digital scope for my 40th later in the year. I might be able to use that to tweak this to the exact frequency. It's there in the you know, the technical document for this, the, you know, tech specs and stuff, the frequency and how you do it. I think you measure one of the pins or something on the output of that chip, and just adjust it to the relevant frequency. It's something like 3.5 something megahertz. I think it might be kilohertz. I think it's megahertz actually. So what else? What I'll do now is I'll just show you how this is behaving, just so I guess it's worth putting it on record really, so that people can see what sort of things you get when you get the problems I've got with this. So I'll just set the tripod up and I'll show you how it works. Right, so if you watch the Sega lettering, you may see the odd artifact there. It's not doing it just now. There you go. Did you see that on the S? And just let the game start. I might need to adjust the volume here. So just turn it down a touch. Now, if you watch the polygons very closely, you may see one just shoot out a little bit. You see like a little line or something that just looks a bit out of place. It may or may not do it on that first. Oh, there's a bit there. Did you see it? It's just on the top of that left-hand side of the star, back of that Star Destroyer. Now, if you watch the text here, it's almost like these are done with vector, like drawn with vectors. And if you watch, say, the W, for example, that sometimes jumps out. It flickered a bit there, but now as the letters come up, just carefully watch the lettering, and you'll see the odd letter, a vector of one point of one of them shoots off. There's one there on the R or the E, and another one there, another one, a few there. Around the V, which is the evil. I hope that's coming across, but you can see just the odd, let's say it's like the vector point is not right. It just shoots off somewhere when it's drawing the lines. So I'll just leave that a minute, and it's quite noticeable there. Sometimes it's hardly noticeable, but on this occasion, I suspect because it's warmed up, it's a warm day today. It's pretty noticeable though. That one was pretty bad. That looks okay there. Now if I start the game, you'll see it'll probably crash pretty quick. Skip that. Sometimes you can see artifacts in this bit. Sorry, it's me pausing it. No, it'll probably lock. There you go. So you've got a freeze. Now the interesting thing is you can still hear the music. What that tells us really is that you've got two SH2 Hitachi processors on these 32Xs, and they work in a master-slave sort of relationship there, where the primary one typically runs all of the code, and the secondary SH2 is used for things like the graphics and sound. I mean, it's not always the case. Obviously it's up to the decision of the programmer really how he intends to use the separate processors to do different things. But typically that's how a lot of the games work. And in this instance, you can hear the music still playing, and that's because the second processor is probably still quite happy, running away through its code there, in terms of playing the music. But the main core mechanics are just locked, so something's going on with the primary processor probably. If I press reset does nothing, which is interesting in its own right. If I switch this off, switch this back on, sometimes it will start straight away like that. Now if you've left it on for a period of time, when it's hung like that, it's really warmed up, the thing's really got quite warm, you'll find that switching it off and on does nothing. You just get a black screen, and you could switch it off for several seconds and switch it back on, and most of the time you'll still get a black screen. You can't get the thing to come back on again unless you switch it off for a minute or two and then switch it back on. So there's a temperature related thing there, and that led me to one of the next points, or next things I'm going to show you really, is that how sometimes temperature can help with these kind of things. Because the nature of this problem, these kind of things where you get random things, you can see the W there flickering away, and it wasn't the first time round. And when you get these kind of intermittent problems that are not consistent, you don't get the same problem at the same point in time each time with the same code or the same action or whatever, it can make it very difficult to isolate the cause of the problem. You could spend a lot of time, you could typically, this sort of problem, you could look at this on, you could get a logic analyzer connected up there and probably reveal nothing. You can, you know, put it on each of the different parts, the different buses there, the different memory banks and things. You can monitor all sorts of stuff with a logic analyzer and pretty much learn nothing from it, because of the nature of this. You know, you'd have to be looking at masses of data to understand where data is changing on the bus, where it's, you know, it shouldn't do. If you see what I mean, you've almost got to have a frame of reference, and when something like this is happening, it makes it very, very difficult to understand, you know, what's going on where. But anyway, right, I'll stop filming there and I'll just show you what I was going to show you. Okay, right, if you're serious about electronics and, you know, getting into repairing some of these things, these are two useful things to have. Some freezer spray. It's quite expensive, this stuff, these days. I remember back in the day when I was in the trade, these were, I don't know, about £2 or £3 a tin or something. It's now about 10 quid. I kid you not, for, you know, £8-9 for a tin of freezer spray. It's ridiculous. But anyway, I guess that's times for you, an economist. And a hairdryer. And just to explain how what got me thinking about the temperature related aspects to this problem. I mentioned that the solder needed redone on these, and it didn't really. As I cleaned those up, the soldering was actually quite good. It was just the flux that made it look a bit of a mess. But I thought, well, sod it, I'm going to give it a re-go anyway. And I did. I went over those again, and then as soon as I'd done that, reassembled it, plugged it back in, and I got some really, really strange graphic stuff going on. I'll see if I can recreate it now. But when that happened, I thought, you know, it's the SRAM, and that's what it is. It's not. I mentioned it as DRAM. Those two chips are DRAM. That's an SDRAM, so it's synchronous DRAM. It's like it was the precursor type technology to DDR. So it's synchronous. It runs at the same speed as the bus. You've got like a clock input somewhere on there, and I haven't looked at the schematics to determine what speed it runs at. I'm guessing, you know, the processors, the Hitachi processors run at 21 megahertz. I wouldn't be surprised if it runs at 21 or a multiple of 21. It could be 42 or something like that. But yeah, so anyway, I'll cut into the chase. I'll use a hairdryer and heat up that shit. Check how warm it is. A bit longer, I think. It's still pretty hot. See, it's not coming on now. After heating that chip up, it will not power up. Sometimes from switching it off and on really quickly, I found that you can get it to come back on. So we'll just give it a sec. We might be able to get it come back on with it. Hopefully it'll exhibit the weird graphical behaviour it did when I tried this last. I might have heated it up a bit too much. Come on. You know, you want to boot. I mean, this in its own right is interesting. Whilst I'm not getting the graphical stuff, the fact that I've just heated up that chip and it now will not power up at all, this is what happens when you've had it on for a period of time. You know, if you've left it on for an hour. Because sometimes I've done that, I've let it hang, you know, just thought, I'm going to leave it on. See what the temperature difference makes, and sometimes that's useful because it can help you diagnose problems with capacitors. You can find that certain things, you know, TVs are a good example, where you can't get them to come on, or they switch off and on and off on their own, you know, and you can leave it switched on sort of in that state for a period of time, and eventually you'll find it will power up, and it's basically, you know, the initial part of the power supply is warmed up, capacitors have warmed up, capacitance values have changed slightly, which is the behaviour you usually get in capacitors that have dried out or drying, you know, in a drying out sort of state. When they get warm, the capacitance value changes slightly, and sometimes that's enough to make the thing boot. Can't get this back on now at all. But what I'm going to do, is just use the freezer spray to freeze that chip. So if you just bear with me a sec, I'll just switch it back on again. And you can see that's now working from freezing that single chip on the board. There'll probably still be graphical corruptions and things. There might be more than previous, depends how well that freezer spray's worked. But it's looking alright. Sometimes you can actually find that from using the freezer spray, a lot of the initial graphical corruptions and things there don't show, and that's another indication that it is, you know, specifically that chip, you target the right chip. I'm not seeing any corruptions at all yet there. It's looking okay. Yeah, it's curious. I'm not seeing, I could have missed them, but I'm not seeing anything just at that stage. Which, you know, like I say, it's pretty strong evidence really that there's something wrong with that chip. I haven't seen a thing. I haven't seen a single thing shoot out there. But you say any minute it probably will start doing it, because it'll just start, the freezer spray will wear off. And its temperature is just going to increase slightly to the point where it starts doing its normal thing. But that looked perfect to me. I didn't see any signs of graphical weirdness or anything going on there. Start this, let's just see what happens. Skip Mr. Akbar. Be interesting to see how quickly this crashes. I suspect it will crash pretty quick. It's going to be hammering that memory now. It's going to be getting warm pretty quick, I would think. Not the easiest game to play this, I have to admit. You tend to just have to let them go behind you, then slow down and just shoot them as they come in front. Because you can't really move very quickly to the sides. So when you see one flying off the sides, you can't get a catch up with it even if you accelerate. But you can see, like, this is the longest it has typically worked. It doesn't, normally you'll get a crash a few seconds into this. It's going to go in a minute, but this is a lot longer than normal based on the fact that I used the freezer spray. So I think on this occasion I'm lucky in that I've identified the cause here based on this temperature scenario. Really, this helped pinpoint exactly which components it is. I suspected the program RAM anyway, as I mentioned previously, and I could look at the schematic and follow it. And yeah, the SRAM, that 2 megabit SRAM chip is shared between both of the SH2 processors. So it was the prime. It was in the targets. It was the prime. It was the chip that I suspected. But this is just pretty much, in my mind, compelling evidence. I'm just wondering when this is going to actually crash. It's surprising. Makes you wonder if a problem like this. There's different ways. Sometimes I like to think about unorthodox ways of fixing these things. Had I not been able to get hold of an SRAM chip, when you look at this on face value, the way this is behaving. What's to say that if you have the relevant cooling solution in place, whether this would actually be a problem? Because those chips, when you switch them on, when it's from stone cold and you switch it on, use it for 30 seconds or a minute and switch it off, take the cart out, feel the temperature of the chips. They are all pretty, just a bit more than lukewarm. So temperature is obviously, an issue here, and it doesn't surprise me because the technology around the era when this was created, these were 21 megahertz processors. SRAM was all cutting edge technology really. And the things were starting to get warm. This is around the, that sort of cycle, that part of the history, if you like, of processor type technology, where processors start to get warmer and warmer and warmer. You start to need heat sinks. It was, PCs of this generation certainly had big heat sinks on. But yeah, so a really good cooling solution. This probably would work. It probably wouldn't glitch. I dare say you'd need a fan or something, and you couldn't really accommodate that inside the 32x case in any way. But yeah, I'm amazed this hasn't actually crashed yet. Anyway, switched it off. I'll show you a few other things now that are worth just covering anyway, just while I'm here. I thought it would make sense really to just cover the standard type of problems you get with these 32Xs. And I know I probably touched on them briefly in the last video, but it's these ribbons. Now, incidentally, one of the things you can do if you've got a problem, as I've done as well, just to rule it out, is you can swap these around. The way these work is you just put a screwdriver underneath, you know, underneath the ribbon there, and just sort of pull it upwards, and these just pull straight out. I can probably just show you, actually. I can probably do it with my fingers. If I just get my finger under there like that, and just very carefully wiggle it slightly, you can see they just come out. They just slide in and out. And somebody, I don't know if you can see it, but somebody scratched the surface of that previously. I don't like doing that. These ribbons are very fragile to start with, and one of the reasons, you know, you get the problems with them is because they don't make a very good connection. So starting to scratch the surface isn't really going to help. You're better off, you know, taking them out, get some isopropyl on a bit of kitchen towel or something, and just wipe them down and put them back in. That's it. Don't start scratching the surface unless they're oxidised or something, and then even then I wouldn't scratch it. I'd get some specialist oxidisation type thing that, you know, you can use for treating metals. And just give it a wipe with that, and you know, clean it afterwards before you reinsert it. But yeah, and they just push back in. Going to be careful. That's it. That's back in. But yeah, it's the same on both sides. You know, they pull out and push back in. So and one important thing to note is you've got these. I've forgot the coil now. It's like a ferrite coil, you know, a ferrite thing, isn't it? Ring that just goes around there, and that just filters out high frequency. So it's important it isn't next to this side. If you put them the other way around, it's not going to work as well, because it's like what these do. They filter out high frequency noise. So if you get any noise being picked up on the length of these cables, you know, here, by the time they hit this, they're filtered to the point they come into the connector there. Sorry, I just knocked the camera. The idea being, let's say, so you're filtering out any RF and stuff, because you don't want noise going into the digital circuit, and that's why you shouldn't put them the other way around. But you can swap these over. They're both exactly the same, so you could, you know, disconnect that one, and swap, you know, put them in the other position, just to rule out. And as I say, I did that just to rule out as well, to make sure there was no cable damage there, and it was exactly the same. So it's a good test to do that. If you get the same behaviour, you know that is not your cause. What else was I going to say? There is. I'll put a link. I might even do it as a separate video. I forget where it is, but there somewhere on here there's a link. I can't for the life of me see it at the moment. I can't remember it goes into this chip here or this one over here. But yeah, there's a couple of pins. I think 2 pins that are bridged or linked or something that sets the region. And if you open circuit, it's US. If you short it, it's you know, sort of European. So I'll probably cover that in another video, but I'll certainly put a link at the bottom of this video showing you you know, what you need to do. In fact, I'll probably just paste the description. It's 2 lines of text. It really is that simple. But I'm going to do that anyway on mine, and the reason being is even though I've got the Mega EverDrive that I use, I can't play Zaxxon on this. There's only seems to be a US and Japanese ROM. And it just keeps coming up saying it's designed for a US Mega Drive. The other thing to note with that is, you know, even though you might have a region-free switch on here to toggle, you know, to do what I've just described, to either open or short those the 2 pins there, to toggle between the 2 different regions, you still need your Mega Drive to be, you know, sort of region switchable. Otherwise, it won't work, because all the region stuff is actually done by the Mega Drive. The jumper on here that changes the region, it's just to do with the identification of the region. So, you know, in theory, you know, swapping it over allows the 32X to not pop up, or or pop up the message to say, you know, it will only work on a US region console, etc. But so there is a sort of basic level of region protection in here, but you still ultimately need to do the region mod to your Mega Drive or your Genesis as well. So coming back to the chip, this SRAM chip, I'll post some links on this. I'm just trying to read, see if I can read it. Yes, it goes the way up, I think. Yeah, it's probably not going to be able to see this. It's really faint, the text, but it's an NEC D4502161 G5-A12-7JF, and it's I think it's 256. Sorry, it's 128K split into 2. So I think you've got like 64K, 2 64K banks, 16-bit. SRAM, as I mentioned. Now, I spent quite a while trying to find data sheets for this, and I was really struggling, and eventually I found a website that luckily had this exact data sheet for this chip. So I'll post a link to that as well on the video, with the video, so you can have a look at the data sheet for that. But I did find the pinouts anyway. They're on the, I think it's Console 5 wiki, and I'll post another link to that. That was on the previous video. But looking at the pinouts, I started, and I couldn't find this chip. I searched everywhere for a replacement chip. Now, the only thing you'll find in Google if you search for this chip is sellers on AliExpress, and it's not actually the chip for sale on AliExpress. I don't know how it works on their website, but it's some sort of link to, you know, they've got loads and loads and loads of part numbers and massive lists, and the idea being is you search and you find that there's a particular seller who can do you a quote. So, you know, you post a message there saying I want 1,000 of these or 10,000 of these, and they get back to you and tell you how much they can do it for. But there's no cost there. You can't just buy one or anything like that. And I haven't had any feedbacks from the 2 or 3 people I've contacted. So, you know, make of that what you will. But I just think it's a waste of time to a certain degree. These people are just trying to, you know, get sales inquiries and certain orders of a certain size. I'm sure they'll probably reply to you. But when you start contacting them, going, "Can I have 10 of this chip, please?" They're probably like, "No, it's not even worth doing a run," you know, because I presume they can still manufacture these things rather than being in storage. If they were in, if they're in stock, I suspect you'd just be able to order them. They'd have the price up there for the quantities and all the rest of it, but that's not the case. So I spent a bit of time then thinking, how on earth, what am I going to do with this? This is, unsolvable really, because if you can't get the SRAM chip, what can you do really apart from what I mentioned earlier, some sort of cooling solution or something? And I really don't want to go there. I'd like to fix this. So I started doing search for SRAM chips of 2 megabit and TSOP, both in Google and eBay and AliExpress, and eventually after a bit of messing around I found a couple of different chips, and one of them I was looking at, and I'll post the model number of this later, and I'll certainly obviously cover it in the next video when I do the repair. But it was I think it was a Hyundai part, and instead of being 2 megabit, I think it was 4 megabit, and I looked at the pinouts, and the pinouts were identical, and it was TSOP, the same as this. So difference, you can tell it's really flat. It's really, really thin. It's definitely TSOP, and it said that in the data sheet for the original part anyway. So I found, like I say, a Hyundai part that was twice the capacity, but had pretty much the exact same pinout. I think as you look at the chip this way, that way up, as the pins come down here, somewhere near the bottom, you've got some of the address lines. I think it starts, and you've got like A6 or A5, A6, A7, A8, A9. On this chip, one of them I think is it's probably not used, but the 6th or 7th one up on the left is not used. And on the replacement chip, you'll find, I think it says BA, which is some sort of bank select pin. And from reading the data sheet of that Hyundai chip, that bank select pin, it's just an additional address pin, as far as I can understand. You might need to use it a specific way, because it mentions about accessing it, or making it high or low when RAS and CAS are being accessed. So, but I guess the other address lines will probably do the same thing anyway. So it's just basically like another address line, and it allows you to toggle between the 2 megabit banks. Hence, it's twice the size. So, considering that pin's not used on here, I started thinking, that chip would probably work. I could just make that pin low, the bank select pin, so that it's always low, and if I'm lucky, it should work. The only thing that I'm not too sure about is with these SRAMs, is this is an older generation chip, obviously, the 4 megabit one I've ordered. Besides having the bank select thing, it's a different manufacturer, and it's rated to go at higher clock speeds. I forget what it is, something like 80 something megahertz or 100 megahertz or something, the type of chip I've ordered. So I'm just not sure, because the way these work, these SRAM chips, there's some sort of commands you can use, control commands, to do with how it pipelines the memory requests that come through, so that things can run asynchronously, over a period of time. And I'm just not sure whether the commands are all going to be the same. Is it going to be compatible? Is it going to have a compatible command set? I guess is the question. And whilst the pinouts look identical, bar the fact that I think 1 or 2 of the address lines are swept over due to that web position of that bank select chip, I don't really see a problem. It's just going to be the commands and the speed. You know, it's a faster chip, so I would think, you know, logic dictates it would work. There could be some issues there with timing, because the different models of the chip there, looking at the data sheet for the Hyundai part, based on you know, which particular model you get, depends on how fast it will go. And there's a table to do with the number of cycles taken to do various operations and things, and I'm not sure whether those are going to be the same. So again, it's a bit of a stab in the dark. It's a bit like that, you know. I mean, we've made more progress. We know that it's definitely that chip. What I don't know is the Hyundai part going to be suitable for that? But there was something like $1 each, so I have ordered like 10. It's going to cost me about 7 or 8 quid, and that's including postage for 10 of them from China. So I guess it's not, you know, it's not a massive financial risk. I'll give it a go and just see how I get on with that, really. So in the next video, when that chip arrives, I'll cover removing this chip and putting the other one on there. And I think what I'm going to do with the other one is I'm going to lift the pin to do the bank select. It's one of the ones sort of around here. I'm going to lift that pin before I put it on, put a wire to the board, a wire to the pin, and swap the wiring around a little bit so it goes to one of the ones on the other side. Because you know, like I say, I think there is a difference there just in one of the address positions of the address pins, and I'm going to then, you know, force the bank select to low. So there'll be a couple of wires on it with yeah, on top of the chip. But yeah, fingers crossed that may solve the problem. And if it does, I guess it's an interesting, useful information for anybody who wants to fix one of these in future, because ultimately that's what's going to kill these over the next decade or two. You're going to start seeing, it's interesting actually, over time you will start seeing different faults in some of these systems. You know, the age-old one, like I say, is the ribbons. There's probably half a dozen videos on YouTube going, oh, you know, you've got a 32x problem, it's your ribbons. Yeah, well, it used to be the ribbons, and the ribbons will probably still be a problem for the next few decades, but ultimately you're going to start seeing different problems. You're going to start seeing DRAM failures and SDRAM failures, because, you know, these parts only last X amount of cycles, operations, years, etc. Processors, you know, probably going to be alright. In these two ASICs, you know, they probably last, you know, 100 years from now. I won't be surprised there's tons and tons of these knocking around where all of these chips work fine, but that won't be the case with these. These will have died, I'm damn sure of it. You might ultimately start getting problems with the caps on the top boards of these as well. Whilst there aren't any problems with this now, you know, I can't really say that would be the case, you know, 10, 20 years from now. I wouldn't be surprised if some of these start being a problem. Then you start getting different behaviours. But it's interesting, you know, like I say, how things will probably change over time. There might not be any of these round in 20 years, you never know. Man might wipe himself out and destroy the planet, yeah. Anyway, thanks for watching. I'll see you soon.